So let's be honest for a second. Have you ever found yourself rating an absolute novel of a text prompt, just desperately trying to get an AI image generator to give you exactly what you're picturing in your head? We've all been there, right? We start stacking adjectives like a giant game of Jenga, describing every single millimeter of a scene, basically assuming that throwing more words at the machine will naturally lead to a better, more detailed picture. But what if I told you that this super common habit is actually making your images worse? Seriously. Okay, let's dive right into this because today we are absolutely busting the myth of the paragraph-long prompt. We're going to unpack a truly groundbreaking new research paper from ByteDance's. It's called Scaling Properties of Text Conditioning in Visual Generation. And listen, this research completely shifts our entire understanding of how we should be communicating with visual AI. It proves, mathematically, that it's not about how much you say to the machine, it's all about the underlying structure of what you're saying. Okay, here's our roadmap for this explainer. First, the long prompt myth. Second, measuring true image information. Third, the structured prompt solution. Fourth, training better image generators. And finally, the power of precision editing. Let's get into it. Part 1, the long prompt myth and exactly why more words do not equal better pictures. Think about how we usually prompt AI today. We write dense, free-form prose. It's basically like writing a novel. It's messy, it lacks structure, and the poor AI is basically forced to guess which of your words are actually the most important. But what the AI really needs is something much closer to an architect's blueprint. It needs highly structured, precise instructions where every single visual variable is explicitly defined, not buried in poetry. And the hard data backs this up beautifully. When we plot this out, tracking the caption length, so the number of tokens fed to the diffuser, on the horizontal axis, and the performance gain on the vertical axis, something really surprising happens. We're tracking state-of-the-art open-weight models here, like QNImage, Hanyan 3.0, and Flux 1. As that prompt's length creeps past a few hundred tokens, the performance doesn't just flatline. Actually, scratch that, it actively degrades. They literally end up performing worse than they did with a super short prompt. The researchers call this prose saturation. Basically, the AI hits a brick wall. But check out the trend for the researchers' new structured prompt method. As they pump more information into this structured format, the quality just keeps rising, completely uninterrupted. The takeaway? Structure scales, prose saturates. To prove this wasn't just some weird fluke, the researchers ran a brilliant little experiment called the fixed backbone probe. They took a single source image and tried to get an AI to perfectly reconstruct it. What they found was that if you just take a natural language prompt and make it longer by dumping in more descriptive fluff about the exact same objects, the image reconstruction stays completely flat, zero improvement. Expanding on existing content with extra prose does absolutely nothing to help the AI figure out missing visual details. So, if counting the sheer volume of words doesn't tell us how much the AI is actually learning, how do we measure it? Which brings us to part 2, measuring true image information, moving way beyond simple token counts. The researchers adapted 2 really clever complementary metrics for this. The first is called grounded perplexity gain, or GPG. You can think of this as a sort of white box metric that fact-checks the prompt. It measures how much more likely a caption is to actually be true when a vision language model is finally allowed to look at the paired image. If adding words to your prompt significantly raises that GPG score, it means you've added hard, factual, image-grounded data to the mix, not just a bunch of flowery adjectives. The second metric is effective detailness, or ED. Now, this is a black box metric. It scores the precision and recall of the specific attributes in the text directly against the actual ground truth image. To put that in plain English, if your prompt mentions a red apple on a wooden table, ED grades exactly how accurately the final image represents those specific, verifiable visual variables. Did we get the reds? Did we get the wood? This all comes together so clearly when we map out the actual training loss of the diffusion model, which just means how well the AI is actually learning the task. When plotting diffusion loss against that GPG metric we just talked about, it forms this near-perfect straight line sloping downwards, hitting a correlation of R equals negative 0.984. That is incredibly strong. It means as grounded information goes up, training loss drops linearly. And when you plot diffusion loss against effective detailness, it follows this gorgeous power law curve. But here is the fascinating part. If you look at the clusters representing standard natural language on these graphs, they completely stall out. Natural language hits a harsh information plateau, but crucially, it lives on the exact same trend line. The model isn't failing because natural language is inherently evil. It's failing because natural language simply stops delivering new, grounded, useful information. Part 3. The structured prompt solution. Basically, JSON for image generation. So the million-dollar question is, we need a way to keep feeding the model structured information without hitting that nasty prose saturation wall. How do we do it? Well, the researchers solved this by transforming the prompt into a JSON-like data schema. Instead of writing a paragraph, a structured prompt organizes all that visual data into neat, addressable fields. You literally have dedicated fields for the global scene context, the rendering style, precise element bounding boxes, so the AI knows exactly where every single thing goes, material attributes, and cross-element relations. It takes all the chaos of prose and neatly organizes it into explicit, easy-to-read components. Part 4. Training better image generators. This is where diffusability meets promptability. But here's the catch, right? How do you actually get an AI to understand and generate these super complex data structures in the first place? Because let's face it, everyday users aren't going to sit around writing complex JSON code to get a picture of a cat. The researchers had to train a large language model to act as a kind of master translator and prompter. They walked it through a really rigorous 4-step pipeline. First up, supervised fine-tuning to teach it the basic structure. Then, cold start distillation. Third, they used verifier-gated reinforcement fine-tuning, which is where the model actually gets rewarded for writing prompts that yield genuinely good images. And all of this culminates in on-policy self-distillation. They literally taught the language model how to take a super simple conversational user request and expand it into a massive, information-dense, structured blueprint for the image generator. And this unlocks a completely fascinating feature when you're actually generating images: the agentic refine, render, judge loop. Because the prompt is now structured data, if the AI makes a visual mistake, say it misses an object you asked for or messes up the layout completely, an AI agent can literally detect its own error, analyze the generated image, and then surgically revise the specific data field in the structured prompt to fix it. It doesn't have to start from scratch and re-roll the whole image, it just tweaks the blueprint. Let's see how this actually translates into real-world results. When you combine that structured diffusability with highly trained promptability, the coherence is just off the charts. We're talking flawless text on signs, incredibly precise object layouts, complex typography that actually makes sense. By feeding the AI explicit, non-saturated information, this system easily, and I mean easily, beats current open-weight models on complex composition and reasoning benchmarks. Okay, part 5, the power of precision editing. Getting zero-shot control via structure. Now we are at my absolute favorite part of this whole explainer: targeted field edits. Because the structured prompt exposes all these underlying image factors as editable data fields, you unlock zero-shot editing that honestly feels a bit like science fiction. You can change one highly specific aspect, like a position, a material, or a global style, and the AI will regenerate the image while perfectly preserving the vast majority of your original composition. No more completely randomizing your image just because you changed one word. Let's look at some specific examples of how this works. We'll start with a baseline study desk setup. Let's say the user decides they want to swap the position of the books. With a normal AI, prompting this change would probably scramble the entire room layout. But here, they simply went into the elements field of the structured prompt and changed the bounding box coordinates for the books. That's it. The books moved, but the coffee mug, the sticky notes on the wall, the lighting, the pens, all of it is entirely untouched. It's incredibly surgical. And we can get even more granular with this. Sticking with that same baseline desk, let's say we decide we don't like those cheap plastic ballpoint pens sitting there. By altering just one specific material field in the structured prompt, literally just changing blue ballpoint pen to brass fountain pen, the AI instantly updates just the pens. Look at the precision there. The entire rest of the desk remains completely unaffected. Let's switch it up to a totally different scene to see how this builds. Here we've got a baseline cafe scene with a mug of hot chocolate. Right next to it is a little jar holding a dried grass bundle. By targeting just that one element's attribute field, we can swap out that dried grass for fresh red roses. It is totally seamless. The hot chocolate itself, the dramatic lighting, the blurred background, zero disruption whatsoever. Finally, let's pull back and look at a massive global scene edit. We take that exact same cafe composition, but this time we change the global scene setting field. We switch it from a warm, late-night cafe vibe to a snowy winter cabin. The entire environment completely shifts to this chilly, frosty log cabin aesthetic. You even get the snow visible right outside the window. Yet it perfectly maintains the central focal points. The hot chocolate mug and the overall layout of the counter are exactly where we left them. This level of zero-shot control is just unprecedented. So, bringing it all together, we really have to return to the core thesis of this incredible paper. Information, not token count, is what scales in prompt enhancement for image generation.
True, reliable scaling doesn't come from writing endless, rambling prose and hoping for the best. It comes from providing structured, undeniable, hard information.
Which leaves us with a genuinely fascinating question to ponder. If structured data, rather than natural language prose, is actually the true native language of visual AI, how is this going to completely change the tools, the interfaces, and the whole way we collaborate creatively with machines tomorrow? Are we going to stop writing prompts entirely and start engineering visual blueprints? Something to think about.